Welcome to part 2 of the CS159 Spring 2020 final review. This will be going over questions 28 through 50. If you haven't seen the first part, it will be linked in the description below. Alright, let's get started. So for problems 28 to 30, we have a few functions with two different arrays of size 5 and a getData function. Let's read the first question. Number 28, which of the following is the output generated by the first print statement in the program above? So why don't we just go through and see what the program is doing. As you can see, there's a size and then there's two arrays, and it's going to set size the result of getData, and it's passing the array by address to getData. So this is going to be actually x, and this is going to be 0. Now there's another size variable inside of getData that is not the same as the one outside in the main function. So we have a do while loop that is going to set size to minus minus start, and that's a prefix operator, so that will happen before the value is assigned. And in this case, it's going to set the size, and this is going to be 0 again, to -1, which is 0 minus 1. And that's increment size to 1. And then it's going to check, hey, does size minus 1, so in this case size is 1, so is 0, is it not equal to -1? In this case it is equal to -1, so this is going to result to false overall, this whole statement here. And then it's also checking if size is less than the size of the array, or essentially are you within the bounds of the array. In this case, as we said, it is equal to -1, so the do while is going to stop and it's going to return size, which at this case right now is in fact 1. So it's going to return 1. So size is equal to 1, and then it's going to print that. And we can see that that is answer choice C. Alright, moving on to 29. Which of the following is the output generated by the second print statement in the program above? So very similar process. It's going to pass a different array, y this time, and it's going to have the start parameter be 3. And if we look down at this logic, we can see that essentially what this is doing is that for every iteration until you either reach the end of the array or start is equal to -1, that it's going to repeat this loop. So in this case, it's going to start with 3, as we can see here, and it's going to start, and the very first time it's going to be 2, and then it's going to decrement to 1, then it's going to decrement to 0, then it's going to decrement to -1. And again, this is array of length 4, so array of length 5, so the index is going to be 0 here, then 1, 2, 3. We won't reach the end of the array, but this is going to be the values in the array 2, 1, 0, -1. And keep in mind, it's not going on to the fourth element because size is at 4, but it's not assigning anything to that fourth value because it's checking the previous element before it goes back to the beginning of the do while loop. Size is going to be incremented to 4 here, so the result is going to return not 1, but 4. And that's answer choice B of question 29. Now we have another question about the function. Which of the following integer values as the second parameter to the getData function would result in returning a value other than 5? So it's asking, in the case of this function, and remember it's independent to the length of the function, it's going to go till the value of start is -1, or it's assigning a value of -1 to that index in the array. And so which of these values would make it so that one of those would result in returning a value other than 5? And remember that the size of the array is actually 5. In this case, if you return 4, it's going to be 4, 3, 2, 1, 0. And that's going to be the entire length of the array. So size would be 5 because it has iterated through it 5 times. It's -1. It's going to be -2, etc., etc. And it will stop at 5 because that's the size of the array, not because of the first condition that it's equal to -1. But if it's 1, it's going to go 1, 0, -1, and then it's going to stop right there because it sees that -1 in the second index of the array. So the answer to 30 is going to be C. Moving on, we have a few true-false statements. 31. Which of the following statements regarding arrays and functions is false? A. It is possible to pass a whole array to a function using the pass by value technique. That is false. You pass a whole array to a function using pass by address, and you cannot pass it by value. It will always be a pointer back to that original array, or it will be an address to that array passed to the array. So this is false, and A will be our answer. Just going through the other answers and explaining why they're true. Returning an array from a user-defined function is unnecessary because a whole array can be passed by address. That is true. We just went over how you're passing those arrays by address, and so you will not need to return the array. C. When passing a multidimensional array to a function, only the name of the array serves as the parameter in the function call. That is also true. You're not going to put any brackets or parentheses or asterisk. It's just going to be the name of that array. So these are both false, and the answer is A. Moving on to 32. Which of the following describes what is meant by strings being variable length in the C programming language? One thing to remember here is that a string is just an array of characters. So you can think of it just like a normal array, except instead of having actual values, it has characters, or it has the ASCII values that are assigned to those characters. So just treat it like an array if you have one of these problems on the exam. A. The capacity of the character array can change during the execution of the program. Well, again, character array doesn't change anything, so if we really just cross this out and we say the capacity of an array can change during the execution of a program, well, we know that it cannot change. Once that array is initialized, it's going to be set to a certain size, so that must be false. B. The portion of the total capacity of the array being used can change during the execution of the program. Now, there's nothing saying you ever have to use the whole array, and especially in a character array, when you often may have a delimiter at the end of the array, that /0, you're not going to be using the entire length of the array, or even if it's an integer array or a different type of array, you don't have to use the entire array. So B is going to be true. And that is what variable length means, is that that array can be a string that is 10 characters long or 20 characters long, as long as the size of the array is greater than the length that you're using it. C. The capacity of the character array is not set until its first use in the program. Again, that's true. You're going to set the size of the array when you initialize it, just as with any array. Alright, so the answer is B. 33. Which of the following statements regarding arrays is true? Using the name of an integer array in the data list of a single printf function will result in the output of all elements of the array. That is false. You cannot just use the name of the integer array. You're going to have to loop through the array. This is not MATLAB. B. All elements of one array can be assigned to another through the use of the assignment operator and only the name of each element. That is also false. That is going to be assigning the memory address of one array. That would be assigning a memory address to another position, and that would not copy the elements. C. The address operator is necessary in a scanf to accept input for an individual element, array element, when using the indexing technique. That is true. When you have a single element from an array, that's going to actually be a variable that's treated as a value, not as a pointer, and so you will need the address operator to get the address of that value or that index. Moving on to 34, which of the following is not a possible outcome of exceeding the defined index range of an array? Many of you may have experienced this when you're doing the labs or some of these things, but A, the program may terminate prior to running to completion. That's definitely a possibility if it runs into some undefined behavior at the end of an array. B, the program may produce unexpected output. That's definitely possible if it's trying to read from an array and the memory that's outside the index of the range of the array is just garbage. Then it may read that and you may get some weird output. C, the compiler may issue a warning message. The compiler will not check if you're exceeding the defined index range of an array. And so this is not a possible outcome, and that's what makes dealing with array issues somewhat difficult, because maybe you just get a segmentation fault and you don't know what that means, and then you have to go ask the group chat what a segmentation fault means for the 20th time. All right, moving on to 35. Which of the following correctly describes the value returned from the string compare function found in the string.h library? This was something that was covered in lecture, and how it works is that it returns 0 if both strings are identical. It returns a negative value if the ASCII value of the first unmatched character is less than the second, and it returns a positive integer if the ASCII value of the first unmatched character is greater than the second. And so we can look at these answers and see A, the value returned from string compare is a logical value 0 or 1 corresponding to whether the two given character arrays are storing equivalent data. That's false. B, the value returned from string compare is a measure of the difference in length of the two given character arrays. That is also false. And C, the data returned from string compare is the first index at which the two character arrays are storing different data. That is also false. The answer is D, none of the above. 36. Which of the following statements regarding the result of the modulus operator is true? A, the possible result of the following for any non-negative integer x is 0 or 1. And it's x plus 1 in parentheses modulus x. Now this is actually a bit of a trick question. We'll talk a little bit more about it as we go through these other options. But we can examine if we have a number such as 2, and we add 1 to it, that's 3. Modulus 2 is going to be 1, right? Draw a little modulus sign in there. And if we have 4, or we have x is 3, then we have 4, and then we have again modulus 3 is 1. And then if we continue to where x is 0, which is still a non-negative integer, we get 1 modulus 0. And that is actually undefined behavior. That will cause a runtime error. And so it will not return 0 or 1. It will crash. And so A cannot be true. Now, B and C are both very similar. And it asks, the result of the following for any non-negative integer x is 1. Okay, well, again, any integer other than 0 is going to return 1. But if you plug in 0, then it becomes 2 modulus 1, which is 0. And then C also asks, the result of the following for any non-negative integer x is 0. And then it has the same expression, but it has 1 minus that expression. So since we already know that this can be 0, we know that this, if x is 0, is going to evaluate to 1 minus 0, which will evaluate to 1. So we know that C and B both be false. And we can see here that these two statements are evaluated the same logical expression. So even if I didn't remember that 2 modulus 1 is 0, I could still look at the logic of these two options and know that if one of them is true, then both of them are true. And since only one answer is correct, that would reduce my answer choices to either A or D, which in this case, D is the correct answer. Moving on to questions 37 through 38, we have a very familiar piece of code that was actually in the midterm 2 review. And it is dealing with short-circuiting and logical expressions. And the first question, 37, which of the following is the output generated by the print statement in the code above? It's asking it prints all of the variables at the end of the code. And I'm going to go ahead and I'm just going to parentheses off because, as you may or may not remember, the AND is evaluated before the OR. So we just go around and draw some reminders for ourselves. Those are straight lines. And again here, except we have to remember. And so in this case, since the AND is in the middle, we have to draw it around the AND. And then we're going to evaluate, obviously, the AND first, and then we're going to go from left to right. Anyway, we go through and we evaluate this just like we did in the previous midterm 2 video. W is 0, and X is 5, 0 and 5 is 0, so this is 0. And then Y and Z, Y is 10, Z is 0, so this is also 0. 0 or 0, so this is skipped, this is not run. Then it goes if not W, so 1, and not X, which is 0, so this is going to evaluate to 1 and 0, which is 0. And then this is not Y, which is 0, and not Z, which is 1, so this is going to evaluate to 0 and 1, which is 0. And 0 or 0 is still 0, so this isn't run. And then it's going to evaluate not X and not Y. Not X is 0, and not Y is also 0, so this is going to be 0 and 0, which is 0. And then not W is actually going to be 1. 1 or 0 is then 1. And then we continue on. 1 or not Z, well, that can short circuit. And we know that the answer is going to be true. It's going to result to 1. And Y will be set to 1. That's the only variable that's changed. This else statement is not run. So the function is going to be W0, X is 5, Y is going to be changed to 1, and Z is 0, which is answer choice B. Now moving on to 38, this is the exact same question actually that was asked in the midterm 2. Which of the following logical expressions from the code segment above are complements? It says, is the logical expressions on line 10 and 14 complements? And let's go ahead and remove some of these markings here to clear up this comparison. So it's asking 10 and 14, are they complements? Well, we can see that they are simply knotted. All the variables are knotted, and the answer is no, that's not enough to make them complements. You actually have to also change out the operators. So all the ands must be changed to ors, and all the ors must be changed to ands. But just changing all of the variables to knots is not going to make it a complement. You're also going to have to change the operators, or you're going to have to put in more parentheses to change the order of operation of the expression. Now it asks, are the logical expressions on line 10 and 18, are they complements? And we can see here that they do change it to not, and they do change the operators, but what they don't change is, again, the order of expression. You have to put these in parentheses to mimic the same order of operation that occurs in line 10. And then it asks, are the logical expressions on line 14 and line 18, are they complements? Line 14 and 18, all you're doing is you're switching the operators, and you're not actually making them complements, again, because you're not changing the order of operation. So the correct answer is D, none of the above. All right, moving on to 39. Which of the following statements regarding the formatting of output with the printf function is true? A, the size modifier is used to specify the minimum number of positions to reserve for the output of a value. That is false. The size modifier is used to specify the total number of positions to reserve for the output of a value. B, a with modifier may be used for the output of any numeric value. That is true. You can use a with modifier with any numeric value, no matter what type. C, conversion codes are needed only for the printing of data that is stored in the memory of a variable. That is false. You need conversion codes for printing any sort of variable or value or anything that isn't just the string that you pass to printf. Moving on to 40. Which of the following statements regarding looping constructs is false? Immediately following the update action of a for loop will be the evaluation of the loop control expression. That is true. This would be, for example, the I++ at the end of the for loop, and then it's going to go ahead and evaluate if I is less than x or whatever value you have there. And so that's true. B, the initialization of the loop control variable must take place outside the body of a do-while loop. One of the benefits of the do-while loop is you know that it's going to be run at least once, so the initialization of the loop control variable may take place inside the body of a do-while loop, making this statement false, and the correct answer for this problem. C, in a while loop, the number of times the loop control expression is evaluated is one more than the number of times the loop will iterate. That is also true. The loop control expression must be evaluated one final time to ensure that it is actually false before the while loop is stopped and is skipped, and the program continues. Moving on to questions 41 through 43, we have two functions, or one function, calc results, that takes 4 integers and has a switch, and then some calculations based on those integers. So let's go to the first question. It asks which of the following is the output generated by the first print statement in the program above. And we can see that it's printing 3 times, all with different options. So in this case, it's passing 1, 3, 4, and 3. And this function will switch based on the first. So it's going to go to case 2. And it's going to set hypotenuse to the square of, in this case, it's an implementation of Pythagoras' theorem of the base squared and the height squared. In this case, it's a Pythagorean triple, so the square root of 3 squared plus 4 squared is going to equal to 5, and that is what it's going to be set with. Then result is going to be set to length times base plus height plus hypotenuse. Length is 3, so this is going to be 3 times 3 plus 4 plus 5, which is 12. So it's going to be set, result will be set to 36. Now, that's the end of the case 2 executables, but there is no break statement, so we have to continue executing down the line, and in this case, we're going to run this last line where it's going to add 1 over option, and divide has precedence over multiplication, so we can add ourselves some parentheses to remind ourselves of that. 1 over option, the option is 1, so this is going to be 1, and then that's going to multiply by the base plus the height, which is 3 times 4, so times 12 is equal to 12, which is going to get added to 36 for our final result of 48, which is answer choice B. Moving on to 42, it asks, which of the following is the output generated by the second print statement in the program above? Print statement 2 is passing 2, 6, 8, and 4. And it's just going to be this last case here, since option is 2. And so, again, we have the parentheses here. And 1 over option is going to be 1 over 2, which evaluated as integer is going to be 0 times the base times the height. So 0 times 6 times 8, but that's going to be 0, and it's going to return that value of 0, which is not one of the results listed. And the answer choice will be D, none of the above. All right, moving on, the third question asks, which of the following is the output generated by the third print statement? So again, we can go back up here and we can look at the third statement, which is 3, option 3, base is 5, height is 12, and length is 5. Now we see that in the case 3 there is a break statement, and so it's not going to run through the rest of this code. It's just going to do this first expression, which is 0.5. Now this is not 1/2. This is not integer logic. This is actually a floating point. So it's only going to be casted to an integer when it's assigned to results. And 0.5 times 5, which is 2.5, times height, which is 12, which is going to be 30, times length is 5, and this is going to be evaluated to 150. Which is answer choice C. All right, moving on to the last set of questions. We have a few more true-false statements. Which of the following statements regarding constants is true? A literal constant is an unnamed constant used to specify data. Literal constant is anytime you write just a plain number in your code, you don't have a name for it or anything like that. It's not defined as size in uppercase or anything like that. So that is actually true. Let's go through the rest of the answers and explain why they're false. While variables have data types, those values represented by constants do not. Constants do have data types. That's why 1 divided by 2 is very different than 0.5, as we saw in the example above. So B is false. C, a constant cannot appear in the data list of a printf statement. That is also false. You can have a constant in a printf statement just fine. 45. Which of the following operators will not necessarily convert the type of the lower ranked operand to that of the higher ranked operand prior to evaluation? We see A, the assignment operator. Well, we know that the assignment operator is not going to convert from the lower rank to the higher rank. It's going to convert to whatever is being casted or whatever the type of the variable is. So it's not going to, and that is actually going to be the operator that will not necessarily convert it. Modulus operator and subtraction operator both don't. The division operator is going to be like the assignment operator, where it's not necessarily going to convert the type of the lower ranked operand to the higher ranked operand, but that is not an option for this question, and A is the answer. 46, which of the following statements regarding the concept of scope is false? A, user-defined functions with a global scope are defined everywhere in the program. That's true. B, the scope of a user-defined function or variable determines the region of the program in which it is defined. That's true. That's the definition of scope. C, a variable declared in the local declaration section of a function has a scope that extends until the end of the program. That is not necessarily true. If that function is returned and is no longer being executed, then that variable that's declared in the local declaration section of the function is not going to exist anymore. It is not going to be in scope of the program. So the answer is C. 47. Which of the following statements regarding functional cohesion is true? As a reminder, functional cohesion is the measure of how closely the processes in a function are related. So A, functional cohesion is the measure of how closely the processes in a function are related. That is true. B, the measure of a functional cohesion is related to the number of times a function is called in a program. That's false. C, a user-defined function that is never called in a program lacks functional cohesion. That is also false. 48. Which of the following statements regarding the switch construct is false? Each case label represents an integral type that is a possible result of the control expression. That is true. Every case label must represent a unique constant expression. That is also true. C, no case label may represent an expression with multiple mathematical operators. That is false, and is the answer. Because the case label does not restrict what expressions are considered valid. You can have 1 plus 1 be your case label, or any sort of mathematical valid expression with as many operators as you desire. 49. Which of the following programs used in this exam does not represent a problem of nested repetition? It's asking, is the problem used for problems number 4 to number 6 the program used for problems number 4 to number 6, number 7 to number 9, and number 17 to number 19? Which one does not make use of nested repetition? So we're going to have to go back and look at those programs. Here's the code for problems 4 to 6. We can see we have a single main function, and then we have a for loop, and inside of the for loop we have a while loop, which is in fact nested repetition right here. So we know that cannot be our answer. Moving on to the code for problem 7 to 9, we have a main function with a for loop with change array inside it. And then inside the change array loop, we have another for loop. So we know, again, there's nested repetition in this program, this code right here. So 7 to 9 cannot be our answer. And then here's the code for problems 17 through 19. And we can see here that there is several functions, but none of them are in loops. And then make string does in fact have a for loop here, but there are no loops within it. There are just selection structures, if, so that is not nested repetition. And then in the print statement here, the print test function, there is again a while loop, but there is no nested repetition within the while loop. And again, there's no repetition within the main function that calls these functions, so there is no nested repetition in the code for problems 17 through 19. So the answer to 49 is C. Question 50, which of the following statements regarding the end of the semester is true? I entirely doubt that any of these are true. Unfortunately, we live in interesting times. I hope you all are safe and well, and good luck on the final. If you find any issues with any of the explanations or have any corrections, please leave a comment